Welcome back, students, to our geometry class. Chapter 4, Geometric Constructions, Practice Set 4.1. So let's begin with Chapter 4, Geometric Construction. In this lesson, the first topic, what we are going to study is the construction of similar triangles. Okay, now in this Practice Set 4.1, you will see here there are 4 questions. And in all the 4 questions, we have to construct the triangles. And you will see that they have given 2 triangles are similar. Okay, in each sum, they have given 2 triangles are similar. And we have to construct these triangles. So how are we going to construct the triangles which are similar? Okay, now if you look at the first sum, triangle ABC similar to triangle LMN. In triangle ABC, AB is equal to 5.5 centimeter, BC is 6 centimeter and CA is 4.5 centimeter. We have to construct triangle ABC and triangle LMN such that BC upon MN is equal to 5 upon 4. So they have given 2 triangles are similar, but out of these 2 triangles, they have given information of only one triangle. That is triangle ABC. And they have given the ratio of the side, one of the side of both the triangle. That is BC upon MN is equal to 5 upon 4. Now children, we have studied about similar triangles, okay, in similarity lesson. There we have studied that when the 2 triangles are similar, their sides are in proportion. Okay, now here if they have given that one of the side of both the triangle, the ratio is 5 upon 4, and if the triangles are similar, then all the 3 sides of one triangle will be in proportion with the 3 sides of the other triangle. And this property we can use to find the sides of the other triangle. Because if we have to construct both the triangles, we need the information of both the triangles. Okay, now I would also like to put your attention on one more thing. That is, if you look at the first sum, that is triangle ABC and triangle LMN. These are completely 2 different triangles. And how you will know this? You will know this from the letters, from the alphabets. Here ABC and LMN, no letter is repeated. So we can make sure that these are 2 different triangles. Why I am telling you this? Because if you just look at the second sum, the name of the triangles given here is triangle PQR and triangle LTR. Now here the letter R is in common. Okay, that means these 2 are not separate triangles, but they are the triangles which are overlapping each other. When we are doing the construction for this, you will come to know. But just to highlight this point, that is, first thing is, here in this you will see, in this particular practice set, there are 3 types of construction. One, where the triangles are completely separate. And then the 2 different types where the triangles are overlapping. Okay, so I will start step by step. The first sum, when we are doing, I will explain you that how we can construct the 2 triangles which are similar, which are completely separate. And how we will come to know, as I just told, that the letters are not repeated. If you see, triangle ABC and triangle LMN, all the 6 letters are different. That shows that ABC is a separate triangle and LMN is a separate triangle. Okay, but they are shown that they are similar. Before we start with the construction, we need to do some calculations. Okay, so first we'll check out that. Now, in the first sum, since they have given that the 2 triangles are similar, I will just write it down first. Triangle ABC is given similar to triangle LMN. Okay. So reason we'll write here given. Now as we have studied, when the 2 triangles are similar, their sides are in proportion. So I will just write that now. AB upon LM is equal to BC upon MN is equal to AC upon ln. The reason you will give is corresponding sides of similar triangles. Now, out of this, as I told you, the information about triangle ABC is given. That is side AB, BC, AC, whatever is given, we will substitute. Okay. So, side AB is given 5.5. LM is not given. BC is 6. MN is not given. Okay. And AC is 4.5. CA is given, that is AC. Okay. Now, they have also mentioned that the ratio of BC upon MN, that is if BC upon MN is 5 upon 4. But BC upon MN is equal to 5 upon 4. If BC upon MN is 5 upon 4, that means all the ratios are equal to 5 upon 4. So if you want, you can give this as 1 and you can give this as 2 and you can give this as 3. So from 1, 2 and 3, if these are the ratios which are in proportion, this is a substitution and they have given that BC upon MN is 5 upon 4. Therefore, all these ratios are also equal to 5 upon 4. So, therefore, we write 5 upon 5 upon LM is equal to 6 upon MN is equal to 4 upon 5 upon ln is equal to 5 upon 4. Okay. Now what we can do is we can take these two ratios along with, that is 5 upon 4 and this 1 ratio, and we can get the sides of LM, MN and LN. Okay. So what we can do is first we will take the first ratio along with 5 upon 4. Okay. Then second we can take the second ratio along with this, and then we can take the last ratio. Okay. And then we can solve this by doing cross multiplication as I have done for all the three. So after writing the ratios, that is the first ratio with 5 upon 4, second ratio with 5 upon 4 and the third ratio with 5 upon 4. So just cross multiply. Okay, and we get LM is equal to 5.5 into 4 upon 5. 5 ones are 5 ones are 5 ones are. So 1.1 into 4 is 4.4 centimeter. Same way, here also cross multiplication, 6 into 4 upon 5, and then we get Mn is equal to 4.8 centimeter. And the last one, again cross multiplication, Ln is equal to 4.5 into 4 upon 5, and after doing the calculations we get the Ln is equal to 3.6 centimeter. Now from this we have got the three sides of the second triangle. Okay, so the lengths of the first triangle, that is triangle ABC, was already given, and then we use the property of similarity, that the sides are in proportion, and we found the sides of the second triangle also. So now it is easier for us to construct both the triangles. Here you all can see that already I have drawn the rough figures, okay, for what we are going to construct. So here you can see that one triangle, that is triangle ABC, whose lengths were already given. Okay. And then we found this LM, MN and LN. Okay. By our calculation. So this is a rough figure which is always done on the right hand side at the top of the paper. Okay, try to do one construction on one page. So whether it is your foolscap paper, you please try that you do one construction on a single paper. So on the right hand side at the top we have written the rough figure, or it is also called as analytical figure. Okay, now we start with the construction. We are going to construct two triangles. Okay, the first triangle is triangle ABC, where the base is 6 centimeter. So we are going to take our scale. Okay. Mark 6 centimeter. This is BC. It is better there and there you write the dimensions. Then BA or AB is 5.5. So for that we need a compass and a scale. Please adjust the compass properly and always take a small pencil, a tiny pencil, so that when you are using a compass, you don't find any difficulty. So now on this, I will take 5.5. Okay, so you can see here 5.5. And now from B, since AB is 5.5, from B, I keep the pointer on B and I make a arc. So this is AB length. Now AC length, which is 4.5 centimeters. So again, I will adjust my scale. I will adjust my compass, sorry, to 4.5. So this is 4.5 now. Okay, on the scale, I have taken 4.5, measured it and taken the distance as 4.5 on the compass. Now AC is 4.5. So from C, the arc what I've made earlier, I will just cut the arc. So this point of intersection what we have got is actually this point A. So AB which we took 5.5 and AC which we took as 4.5. So again we need a scale. Okay, and this is 5.5 here centimeter and this is 4.5 centimeter. So this is our first triangle. In the same way we are going to construct the second triangle just next to it. So the base is MN, which is 4.8, which directly we take it on the scale. So MN, which is 4.8. Now ML or LM is 4.4. So on this, take a scale and try to adjust the compass to 4.4. So I'll do it. Okay, so this is 4.4. Now from M, because LM is 4.4, so from M, I'll make an arc of 4.4. And now LN or NL is 3.6. So again, I have to change the compass to 3.6. Okay, so every time keep it down on the table and do it. Don't try to hold it in your hand and do it. Put the scale on a table and then you adjust to 3.6. So here I have adjusted this to 3.6 and it is LN or NL is 3.6. Therefore from N, I have to keep the pointer on N and I will just cut the arc what I've made earlier. And the intersection, the point of intersection what we get here is point L. Now how I come to know all this? Because of the rough or the analytical figure. So analytical figure is very important because it will instruct you, it will direct you in what you have to do in order to get the construction. Okay. So now I just join this here. Again, not to forget to write the lengths or the measure or whatever or the letters on the actual figure also. So your actual figure has to exactly look like the analytical figure. Okay, that is the figure what we have done here as rough. Okay, this need not be of the exact measure, but it should look like it. So this need not be 5.5, this need not be 6, but the triangles should look like this. Once this is your original construction. Okay, I hope it is understood. Now after we did the first sum here, we move to the second sum. Now as before beginning with the first sum, I had explained you that you have to check that the letters of the given triangles. If they are completely different, then we have to construct two different triangles, what we did just now. But in case if there is a common letter, so you can see the second sum, PQR and LTR. This R letter is repeated. So here you should know that these are not two separate triangles, but there is a point which is in common between the two triangles. So these are the overlapping triangles which overlap one inside the other. Okay. Now here the information of one triangle is given, that is about triangle PQR is given. Okay. But we have to construct both the triangles and one ratio is given. Okay, ratio of the side of both the triangle here, PQ upon LT is given as 3 upon 4. Now, as in the first case, we did the calculation from where we got the sides of the other triangle. Here in this case, we don't have to do that calculation. Okay, because these are this is the second type of construction what we are going to study, where there is a letter in common. Okay, and here we need not do the calculation as we did for the first one. Okay, first one, since there was nothing in common, in order to find the measure of the second, we had to do the calculations. But now we will see how we will proceed with the second one. Now here you can see for the second sum, I have already done the analytical figure. Okay, from this figure first I will give you some explanation before I begin with the construction. Now since it is given that triangle PQR similar to triangle LTR, and I told you that you have to pay attention if there is something in common. So here you can see this letter R is in common. Therefore this is a second type of construction. Here as I told you that the triangles are overlapping. Now you can see what is overlapping. So this is one triangle here PQR. And this is a second triangle here LTR. Why it is shown like this, one inside the other or overlapping? Because R is in common. This letter R is in common. Okay, if nothing, no letter is in common, no alphabet is in common, then the first construction what we saw, that you will get completely two separate triangles. But before you do this, we have to do the calculation which I have shown you earlier. Okay, so now coming back to this. Now here again in this type also there are two types. Okay, where there is a letter common, there are two types. And what are those two types? It depends on the ratio. Now if you see the ratio given is 3 upon 4. So in this ratio you will see that there is a smaller number which is in the numerator and the bigger number is in the denominator. And in the second type, the bigger number is in the numerator and the smaller number is in the denominator. Okay, so in this case, now you will see that the information of PQR is given. That triangle is inside. And which triangle we have to construct? We have to construct LTR. Okay, and that triangle you will see that the triangle is outside. PQR, the information is given, it is inside, and LTR, the information is not given, is outside. So in this case, where the smaller number is in the ratio, the smaller number is up in the numerator and the bigger number is down in the denominator, then the triangle whose information is given always comes inside. So these are the simple things which you can keep in mind when you are solving. So you can counter check after you finish your construction whether you have done the proper construction. Because usually we tend to make a mistake that this triangle which is inside, while constructing it goes outside and the outside triangle goes inside. Okay, so I will just start with the construction so you will come to know. Now since the analytical figure, you can see there is something shown here down. Okay, so here we have to draw this ray from R and we have to take these equal intervals. I will explain you how to do this. So before we start, as I said, that we have to construct the triangle whose information is provided. Now out of PQR and LTR, the triangle PQR, its information is provided to us. So we will construct that triangle first. And as I told you, when there is a letter in common, then we don't have to find the information of the second triangle. Directly we can do the construction. So what we have to do is we have to construct triangle PQR first. For that, now one more thing. Before we begin, you have to first check that which letter is in common. So if you see here, the letter R is in common. Correct? Now, the letter which is in common, try to take it at the base and towards the left hand side. There is no hard and fast rule that it has to be at the left hand side, but it is more convenient. Okay? So therefore, the letter which is in common, try to keep it at the left hand side and towards the and at the base. Okay? So R is the letter which is in common. Okay, therefore I've kept it on the left hand side, and it is the vertex of the or it is the alphabet which is at the base. So I will first take RP, which is 4.8. Okay, so I just adjust my scale. So this is 4.8 here. Okay, so this is RP. Now you might have a question that can we take RQ as the base? Yes, you can take RQ as the base. Since I have said that R has to be the letter which is in common, has to be on the left hand side and as a base. So RP can be the base or RQ also can be the base. If RQ becomes the base, then this T will come here and this L will go there. Okay, so it is understood. Okay, now, so as I first did this, I will write here 4.8. Now, RQ is 5.4. So what I do is, I take a scale and this is 5.4. So just adjust 5.4 and then just keep here. Since it is RQ, I am keeping on R. I make a arc. And now this QP, okay, QP or PQ is 4.2. So I just adjust again. Yes. So PQ or 4.2. So I make this up. And this point of intersection is point Q. So this is the triangle PQR whose information was given. Just keep in mind that the alphabet which is in common has to be at the base. So it can be here or here, as I said, but it is more convenient to keep it on the left hand side. Okay, now this RQ also can be the base. So if RQ is the base, then this P will go here, Q will come here, and the measurements also will change. So the base will be 5.4 in that case. I think it is understood. Okay, now after this, after we do this, this vertex R, this is the letter which is in common. From that vertex, we will draw a ray of any angle. Okay, of any angle. But see that it is not 90 degree. It is an acute angle. Okay, so this you don't need to take a protractor, because this you can take any measure which is acute angle. So it is to 30 degree, 40 or 50 degree, like that. Okay, after that, after we draw this ray, what we have to do is, this ratio is given. Out of this, which is the bigger number? 4. So whichever is a bigger number in the ratio, that many equal parts we have to make on this ray. So equal parts means we can just reduce this. Okay, and since the 4 number, 3 upon 4 is a ratio, so 4 is a number which is bigger in that ratio, so I have to make 4 equal parts. So what I do is I keep the pointer on R. This is the first part. I keep the pointer on R and I make this distance can be anything. It should be a little small only because we have to make 4 parts. Sometimes we have to make 6 parts, 7 parts. Depends on what is the number on the ratio. So now the second part when I'm making, I'm keeping the pointer on this arc. And I'm same distance. Please don't change the distance because we have to make equal parts. So I make the second part. I keep the pointer on the second arc. I make the third arc. I got 3 parts. Now one more part. So I make the fourth part. Okay, so these are the 4 parts and we label these arcs as R1, R2, R3 and R4. Okay, so these are the 4 parts, equal parts which I made. And why I made 4 parts? Because I told you that you look at the ratio and whichever is the greater number in the ratio, that many parts you make. Now why? Because we have to construct the second triangle whose information is not given to us. Now after we make those parts, now in the ratio, which is the number at the top or the numerator. So the number 3 is in the numerator. So whichever number is in the numerator, that number we have to join to this vertex, the other vertex of the base. So since 3 upon 4, the ratio is what? 3 upon 4. Therefore the number 3 which is in the numerator, whichever number is in the numerator, that number we have to join to the other vertex. And we have to construct a congruent angle. Okay, we have to construct a congruent angle to this angle at 4. Okay, so what I do is I will just extend and you have studied how to use a compass and construct congruent angles. So what I do is I want to construct angle, this congruent angle at 4. Okay, why I joined the third? Because in the ratio, third part is in the numerator. So what I do is to construct congruent angle, I keep the pointer, I just make it very small distance and I keep the pointer on R and I make a small arc. Okay, to be very careful because it is a very small angle. Now same distance I'll keep on 4. I'll try to make a bigger arc. Okay, now I have to count this distance. I have to count this distance and adjust my compass so that, see, I have to count this distance. Okay, and same arc I have to make from here. See, this arc has cut this at this, so I'll just make a arc. So what I did is first I made equal arc, this arc and this arc. Then I counted this distance and I kept the pointer here. Since I counted from here to here, I kept the pointer here and I made an arc. If you see here, this is the point of intersection, okay, of this bigger arc and this smaller arc just now. And we have to just draw this point and it should reach up to here. So what is, it should be also parallel to this line. Okay, therefore what I do is I hold it here, I drag it and I try to see that whether it is, yes. Okay. Now, when it reaches here, okay, I'm going to make a congruent angle to this at this point. Okay, so same method. I keep the pointer any distance, try to keep the distance small. I make an arc, and with the same distance I'll keep it here and I'll make an arc. Now I have to count from here, from the base. I have to count how much is this distance where it is cutting this, and I keep the pointer here and I just cut it. Now I have to join that intersection. For that, first I will extend this. Okay. Now whichever line I'm drawing, see this arc you can see, and this, okay, it should be also a parallel to this. So yes, I've got it. So this, so you can see now we have got this bigger triangle which we were looking for, and that is how you are going to label it. This will be your point L and this will be your point T. The reason is here RQ corresponds to RT. If you look in the name of a triangle, I'm writing it close here so you can understand. Here. So if you see here PQ corresponds to LT. So where is PQ? PQ corresponds to LT. QR corresponds to TR. QR corresponds to TR. And PR corresponds to LR. So PR corresponds to LR. PR corresponds to LR. And accordingly you're going to. So don't make a mistake of writing this T here down and L up, because you have to check the correspondence. P corresponds with L. So where is P? There L should come. Q corresponds with T. So where there is Q, the T should come. And R is common. So this is a construction. Now if you see here that the information of PQR was given, it is inside, and the information of the other triangle LTR was not given, which has come outside. And when it happens, when in the ratio the smaller number is in the numerator and the bigger number is in the denominator. So after you finish your construction, you can check that in the ratio, if the smaller number is up, then the required triangle should be outside. And which was the required triangle? LTR. Okay. So just to counter check after you complete your construction. Now after the second sum, the third sum is for homework because it is similar to the first sum. Okay. In the first sum and the third sum, they are similar because if you see the names of the triangle RST and triangle XYZ are similar. There is no letter which is in common, and therefore the information of RST is given and a ratio is given. So we just have to find the lengths of the other triangle, that is triangle XYZ. Okay, and then you will construct. So first calculation where we will find triangle XYZ lengths, and after that we are going to construct the triangle. Now here they have given one angle. So here we have to use the property that in similar triangles the angles are congruent. Okay, so from this information you will get two sides of triangle XYZ, and if angle RST is 40 degree, then angle XYZ is also 40 degree. Why? Because in similar triangles the angles are congruent. So when you're doing the calculation, you will not get the three sides because they have not given three sides. They have given only two sides of the first triangle. Therefore, you will get the two sides of the second triangle and an angle 40 degree. So that angle, if RST is angle RST is 40 degree, then angle XYZ is also 40 degree. So you have to construct a triangle with two sides and one angle. And you have studied this in the earlier standard, how to construct a triangle when two sides and an angle is given. Okay, once you construct, you have to construct the other triangle also same way. But before that, please do the calculation where you will find two sides and an angle of triangle XYZ. Okay, proceeding to sum number 4. Now in sum number 4, if you see the name of the triangle AMT and triangle AHE. Now here the letter A is in common or it is repeated. Therefore, this is not the type of construction where we are going to construct two separate triangles. But this is a construction where the triangles overlap each other. Now, as I told you, in this also there are two types. The first type where in the ratio smaller number is in the numerator and the bigger number is in the denominator. Now, this is the ratio where the bigger number is in the numerator and the smaller is in the denominator. So, in this case, what happens? Okay, so you follow the steps what I am explaining and then you can counter check whether you have got the construction correct. Okay, we saw in the sum, okay, that is triangle AMT similar to AHE and the ratio is given. So here the information of one particular triangle was given. Okay, now I have already drawn the analytical figure. Now this information of triangle AMT was given. There, as I told you that since A letter is in common, that should be always at the base and towards the left hand side. So we have taken this A down. Okay, now they have given AM and AT and angle A is given. So here I have taken AM as 6.3 as the base, then this angle 50 degree and then AT as 5.6. With this we can construct the bigger triangle AMT. And then same method, you have to just draw a ray from the common vertex A down and then how many equal parts in the ratio which is the greater number 7. So if the 7 is a greater number, that many parts we have to make. Always remember how many parts we have to make in the ratio, the greater number, that many parts. So 7 equal parts. Out of that, which is the number in the numerator? 7. That you have to join first. Okay, so as I'm doing the construction, you'll come to know. So as I said, again I'm repeating that this AM I have taken here the base. You all can take AT as the base. So if you all take AT as the base, then T will come down here and M will go up. So if AT is the base, then 5.6 is the base and AM will go over here, so which is 6.3. So anything you all can do, you can do by this method here as I have taken AM as the base, or you all can do it by taking AT as the base. Only thing is that A should be here on the left hand side and down. Okay, so I begin. That is, I will first take 6.3. Sorry. Okay, I will draw a longer this ray and maybe I will mark it afterwards. So 6.3 is here. Okay, so this is point M, this is A, so it is 6.3. Now they have given angle 50 degree, so we'll need a protractor. Okay, so this is the protractor, so we have to mark 50 degree at A. So just keep the protractor. 50 degrees acute angle, please keep in mind. And AT is left, which is 5.6. Now that AT we have to take the compass. So on the compass, please take 5.6. Okay, since AT is 5.6, from A I will mark a arc of 5.6. This is T. So I just join. Before I proceed, I make sure that I write this is 5.6 centimeter. Okay, this is a triangle which we have constructed whose information is given. Now we have to construct triangle AHE whose information is not given. So after this, the first thing what comes is we have to draw a ray moving downward from the common vertex. Which is the common vertex? A. A is the common vertex. So from that A, we have to draw a ray making an angle with the base of about 40 or 50 degree, whatever. But it should not be 90. It should be a little lesser. That is, it should be an acute angle. So no need to take the measure. Just draw a ray like this. Okay. Now, since the ratio what is given is 7/3, which is the number which is greater in 7 and 3? 7. So that many parts. So always keep in mind how many parts we are going to make on this ray. Look at the ratio and whichever is the bigger number there, that many. Okay, so I will just adjust my compass. As I said, please take a very small measure so that you have to make 7 arcs. No, it should fit. So first, same method. Second, now where I made this arc, there I will hold this pointer and I'll go on making arcs. And how many arcs we have to make? We have to make 7 arcs. Okay, so 1, 2, 3, 7 parts actually. So 1, 2, 3, 4, 5. 2 more parts. Okay, so this last arc, I will keep the pointer on that, this pointer on that arc, and I'll make an arc with the same measure. Okay, so in this way, we have made 1, 2, 3, 4, 5, 6, 7. 7 parts. And we have to name these arcs A1, A2, A3, A4, A5, A6 and A7. Now after this, again we have to see the ratio. The number which is in the numerator, 7. So here A7 we are going to join with the other side which is there on the base. Okay, so since 7 is there, we are going to join 7. If it was 3/7, so if 3 was at the top, then we should join 3 to this other letter on the base. One letter is A and the other letter, the other side, the other vertex of the triangle, there we are going to join. What we are going to join? The number which is in the numerator. So since 7 is in the numerator, now I will join this 7th arc to this vertex here on the base. Okay. Now I have to make a congruent angle, where this congruent angle I have to make at 3 because the other number is 3. So at 3 I have to make this congruent angle. Okay, so for that I need the compass again. Okay, then as I said, try to take the smallest distance here between the pencil and the pointer, and I'll make an arc first. Again, you'll ask what distance? So a very small distance. Okay, now this arc what I have made here with the same measurement, I'll keep on 3 because the other number is 3 on the ratio. So I'll keep on 3 and I'll make a little bigger arc. Okay, since we have to make the congruent angle. Now I'll measure from this base here to this other side. I'll measure. Okay, so basically I have to know how much is this distance between these two arms. Okay, so that I will count, and then I'll keep the pointer on this base here again, and I'll cut an arc here. I have to be very careful because it's very small distance. Now I will join this and this. Okay, so the intersection of the arcs with this A3. But again, that line has to be in parallel. So I will start from here and I'll just drag it up to A3. And I'll also check whether it is passing. Yes. Just make sure that it looks parallel also. So, and it has to, because if you have done your congruent angles, that steps properly, you will get it. Now, this angle, I have to draw a congruent angle at this point here. Okay. So again, same procedure. We need a compass. Keep the pointer on M. I make a small arc. Same distance I keep the pointer here. Where I have drawn this line now, where it comes here. I have kept the pointer here. That is actually pointer H. So I'll make an arc. Just need to hold it properly. Now I want from here to this point. Okay, wherever I have drawn that arc, no? So from this middle distance I want. Now I keep the pointer here and I make an arc. Now the line will pass through this point and this intersection. But again, since it has to be parallel, and just drag. Yes, it is. You can see it is passing through this. Now, how to name this? This is AHE triangle we have got. So the triangle is actually AMT, similar to triangle AHE. So A corresponds to A, M corresponds with H. So M corresponds with H. So this is point H. And T corresponds with E. So T corresponds with E. So this is a required triangle whose measurements were not given, AHE. AMT were given. I hope it is clear. Now you will see that we have completed, out of this 4 sums, 3 sums are done, okay, in the video, and the third sum I have given for homework. Even that I have explained you how to go about. It is similar to the first one, but only here in this triangle, in the first one, all the 3 sides of the triangle were given, and in this third one, 2 sides and an angle is given to construct. Okay, so please go through all these 4 sums, 3 sums in the video, and you have to complete all these 4 sums in your notebook. Again, a reminder, 1 construction on 1 page. Thank you, children, and have a nice day.